We do a lot of work with automotive, especially fabrication shops. Now, most of the time, if these guys are buying 3D scanners, they're reverse engineering like the new Bronco bumper, and they're fabricating parts to put a new light bar on that. And so they'll get the actual data and then design around it. And then when they print the parts, a lot of the times they're using carbon fiber nylon or carbon fiber polycarbonate. Less commonly, they're using Ultim 9085 for things like intake manifolds and HTN CF for also intake manifolds along with polycarbonate CF. And then we get a lot of brackets and we get intakes and all sorts of stuff. So today, we've got a pretty cool project. A guy called in saying, hey, I want you guys to print 2 of these parts. And we're like, okay, we do print service, but it's usually higher end stuff. We don't really necessarily, he's like, come on, this is a pretty cool thing. You know, I got this old Porsche and they're NACA ducts. It's going on a race car. So I was like, you know, that sounds pretty cool. All right, let's do it. Let's look into this. Send us the parts, we'll check it out. And we found it, we saw them, we checked it out. It's a pretty cool part, pretty easy, pretty simple. And we said, that's a great example. So today, we're gonna 3D print a custom one. What we're gonna do is we've got some options. This part is going on the bottom of an engine bay. So it's not really gonna see a lot of heat unless the car is sitting still. When it's moving, there's gonna be cool air flowing through it, so it doesn't really need that much temperature resistance. Now, when we did the actual part, I believe it was in HTN CF25, which is a PPA nylon, or performance polyamide, which has a higher temperature resistance or heat deflection temperature than your regular nylon 6 or nylon 12 or nylon 11. So it's higher performance in high temp environments. Today, we're gonna use a material that's pretty robust for a lot of applications, known as PA6 plus CF, or nylon 6 with carbon fiber fill. This is about 10% carbon fiber filled, giving it more rigidity than regular nylon. And if you're wondering what nylon is, well, obviously women's nylons that they put on, legs and stuff, and then there's zip ties. Everybody knows zip ties. That's generally nylon. There's also a lot of other products and applications for it. It's really high impact. The carbon fiber stuff drastically lowers that impact resistance. It actually becomes more brittle and it'll shatter easier, whereas regular nylon will just take a beating and it's like no problem. So the combination of these two things, giving it a little more rigidity, but still having the ductility and robustness of nylon, is just a good overall option. And the heat deflection for this stuff is 150 Celsius. So that's almost 300 degrees Fahrenheit, which is good for a lot of stuff. One of my favorite materials, hands down, easy to print when you have a heated chamber, which is why we're printing it on the 22 IDEX V3. This thing has nozzles that'll go to 500, a chamber that'll go to 100, and a bed that'll go to 200. So it's overkill for this material, but it'll do it at the highest possible quality, meaning you get great layer adhesion, awesome dimensional accuracy going throughout the entire part. And it's a big part, it's about that big. So having that build volume of, 14 by 14 by 17 plus, it's like a little bit more than that. You get a lot of real estate in this printer to print parts. So we could actually probably print 6 of these at a time. But for today, we're gonna show you exactly what the process looks like to print one, from slicing to removing it from this build plate right here. So let's get started. Okay, so the first thing you want to do is preheat your machine. So we're going to set the machine to be at around the printing temperature. If your chamber's at 80 or 90 or 100, set that. So we're doing CF nylon PA6 plus CF, so it'll be around 130 on the bed. And for the actual printing nozzle, we're going to print at 290. We don't need to preheat the tool head. We just need to preheat the actual chamber to soak the frame so that there's no shifting or anything due to thermal expansion. When you're at these high temperatures, even at the nozzle, there's slight change in expansion down to the fractions of a millimeter, but that will affect your print. So always preheat. And then of course you want to prep your plate with Nano Polymer Adhesive, because this stuff will save you money over time just by your yield rates. Using a really good build plate and a really good build plate adhesive keeps your prints stuck to the bed so that they don't curl up and you lose that entire part. Especially terrible on a 36-hour overnight print or some crazy thing like that. You don't want to come in at the last hour and see that corner was just peeling up. So grab a bottle of Nano Polymer Adhesive, fisherminer.com/adhesive, or your local Amazon, or 3D printing influencer. There's a good chance they got a little code to get you a deal off of fisherminer.com. So we're gonna just sort of spread this around the general area of the part like so, and then just even it out. And so I'm gonna make sure that it's relatively spread out. I don't need to do the whole plate. And if I'm gonna print this part over and over and over, then I could just look at exactly where the part was on the plate and simply reapply more nano to those areas to keep it refreshed. Now if there's a PLA or something like that, I'll give you a little secret. I've printed over 45 prints on the same coating of Nano Polymer Adhesive. I've probably done more now with the consumer machines we got out in the back that we use. Just one coating will last for a month of constant printing. It's crazy. This stuff is literally like gold. It's nuts. Check out the reviews on Google, on Facebook, all over the internet and Twitter or X. It's some crazy stuff. Really happy about it. Really surprised personally. We didn't see it going that good, but there we go. So I've got my nano adhered. Now I am going to use a glove for this because when we put this into the machine with the hot build plate, I'm going to tighten the screws. So let's do that right now. All right, so we're just gonna set this right here on the edge of the build platform and slide her in. Make sure it's back against the two back set screws and then tighten those down by hand. You do wanna make sure these are nice and tight. Not super tight, because if they're too tight, the expansion in the build plate can actually cause damage. It is an aluminum build platform, so you want it tight enough that the build plate itself isn't going to shift at all during the printing. So just finger tight does the trick, gets the job done, and now the build plate is heating up. So because the build platform was hot and the build plate we put in there was cold, it caused a temperature differentiation that was extreme, and the machine is like, uh-oh, heater fault, something's wrong, let me turn it off. That's one of the safety features in this, so you don't have issues like that come up. So I'm gonna go ahead and just close it, and I'll go ahead and just click bed heater, and then it will allow me to reset the fault. Really not much lost here, and then I click it one more time to turn it active, and it's gonna go right back to that set temperature. So now you can also see here, we've got the chamber air set to 90. So that's been sitting there. It's currently at 79. We had the door open there for a minute, so it's gonna heat back up gradually. As you can see, right here on the chart, it dipped down and it's gradually going back up. So this is the chamber heater temperature and the chamber air temperature right there. Fully correlated. So our machine is preheating. Let's go ahead and slice the part. I'm gonna open up Prusa Slicer here, and you can see I've got my part. If I didn't, I could just go like this and take my STL or my 3MF and dump it right in there. Now, a lot of times your parts will come in like this, really easy. Just hit this button right here. You can place it on the face, whichever face you want. Now, probably not that way. That might work, but you'd have to have a bunch of support material under all this. And this might work too, but then you got all this support material inside that area. So we are going to go this orientation right here. I'm gonna select my object and hit the R key to then rotate it. And if I stay in the center, it'll snap, or I can snap to certain degrees, or I can go free form. So I'll just snap it right there so you can see it as it's printing. All right, and if I want, I could even go to this mode. There's not multiple parts, so I can't auto arrange, but I'll just put it in the center there. Right now, for supports, it's usually more efficient and just preferred to paint on supports. So what we're gonna do is we're gonna go right over here to this, the paint on supports. Now I can see the left mouse button and right mouse button. This will block supports and this will enforce supports. Wherever the blue is, it's gonna put supports, and wherever the red is, it's gonna make sure there are no supports. So for this part, in this orientation, all we need is this area under here. So I'm gonna give my brush a little more size. I'm just gonna give it a good amount, and I'm gonna go under this bottom area. Let's go for this whole area, probably up to right about there. Not that. Just gonna make sure all this stuff is well supported. Just like you, when you buy from visionminer.com, we sell 3D printers, 3D scanners, and we have full support right here in the USA. We support every product we sell, and customer relationships are really a cornerstone of our business. Everything here looking well supported, but I need to change to a circle and then erase all this. So I'm gonna hold Shift while I paint, and it's gonna get rid of that painting. So now my front lip has nothing, but all this rest of this lip does. Probably don't need it there. That's reaching the angle of which we can trust the material to just simply have an overhang, but still get good part. I'm gonna really just go up in that area. So now let's go set up the supports themselves, some settings and some styles of supports so that we know what we're gonna get. I'm gonna go into print settings and support material. So here we've got it set to organic. Now organic supports are gonna be much more efficient, and they're gonna look like trees. They're gonna go and build from a bigger circle up into smaller circles all the way up until the interface with the part. If we did normal supports, it would just be a grid pattern and a solid block. Tree supports tend to be faster, tend to be nice, easier to remove, stuff like that. And they look pretty cool. So we'll use organic supports on this, and looks like we've got a 0.19 interface. So we're gonna go with that for now and see if that works. Big thing you could do, we're just gonna run with it in this video. But if I wanted to be sure that my supports were gonna work perfectly and be awesome, I would want to print this multiple times. But as you can see, when we slice it, this part takes approximately 11 hours and 47 minutes. So we do not want to print it multiple times to tune in a specific feature. I'm gonna get out of the support paint, and I'm going to select my part and hit this cut button. This feature is powerful. First thing I'm gonna do is I don't need anything above the overhang. That overhang right there, I'm just gonna go right above it. And I'm going to delete object A, which is the teal, and keep the magenta object B, keep the orientation, perform the cut. And now I'm gonna go even further. I'm gonna do another cut. Let's do this at 90 degrees. So I'm gonna go right over to here. Yeah, we'll keep one of the holes in there. I'm gonna do the same thing. I'm gonna keep object B, and one more time. Oops, let's zoom in a little bit. I'm gonna go right here. Gonna bring it right about there. Perform cut. Oops, I did that wrong. Let's go back. Boom. I wanna keep object A this time, not B. Perform the cut. Now it auto placed it. I don't want that. I want to have it selected, so let's reset it back in that orientation. But then I'm also going to do one final cut just to bring that. Oh no, let's do it that way so that I keep, oh, whoop. There we go. Perform cut. Now I'm going to lay it back on its appropriate side one more time. And there we have it. So there we have just the part to do the support tuning. Now let's see what that looks like. All right, an hour and 27 minutes. Oh, no supports. Well, that's because we modified the actual part, so we have to go back in there and repaint the supports. So I'm gonna go back in here, select my object, paint support menu, and we're gonna go do this whole under area. All right, so now I can also get rid of that. Probably don't need it there, probably don't need it there. And we could really dive into this. We could test, different versions of where we paint the supports. We could test the type of support. We could test, do I actually need this little lip right there, or can that just be free hanging? Maybe that can be free hanging, who knows? So once you have some of that stuff on there, then slice it, and let's see some beautiful supports. Okay, so here we go. We've got organic tree supports. Look at that, absolutely crazy looking. But this is what you would want to do to make sure that these settings are gonna work properly for you and your part before printing the whole 12 hours. It just makes sense. You cut this, in an hour. We could make this smaller and get there even sooner. Like Do we really need all that buildup for the overhang? That's a great question. Yes and no. You could cut off the bottom of this part right about there and just have it go up a little bit. But what I like to do is actually simulate the heat from the build plate up to the part that's being supported. Because if I bring it really low down to the build plate, then the part itself is gonna receive the heat from the build plate, and it's gonna affect the results a little bit. Even having the whole geometry will affect the results because the amount of time it has to go around the whole part versus this little area, right? It's different. So this isn't perfect, but it'll get you a lot further, a lot faster. So let's go back. I'm gonna hit Control Z a whole bunch of times. And we'll go back into the paint on supports. Looks like I still got it. Still got it, we're good. But I'm going to use a smaller sphere. I do not want supports inside these little holes. These holes are small enough, those overhangs won't be an issue. And if the support is inside those holes, they'll be a pain to remove. So I'm gonna go in here with a sphere, but a little sphere. That'll get the That'll get the three-dimensional space, and let's just get rid of that, and get rid of that. And we'll get rid of that, and that, and that. I'll change the angle, again, just right in there, right in there. I'm holding the middle mouse button to just scroll over like that. So if I click, if I click in the background, I can rotate. If I hold the middle mouse button, I can just slide it. Quick tip for you. All right, there we go. All right, now the back is still looking good. All right, we're ready to slice. Let's check our settings one more time just to go through everything and see what we're looking at. So layers and perimeters. Looks like we got 4 perimeters for this, just to make it a little stronger. If we had 3, there'd be gap fill, and a lot of times it's more efficient to make sure that your walls are all straight lines. And if we go throughout the rest, skirt and brim, we're not using a brim, so that's set to 0. We got support material, threshold is being overridden because we're using the paint on supports. Pattern spacing, interface loops, speed. We're using volumetric speed. So this whole 100 millimeters a second thing, ignore that. We're really looking down here. The max print speed is 200 and the volumetric speed is set to 12. And that's a ratio thing. And so we found 12 is about perfect for CF Nylon. These are all profiles that you can download when you receive your 22 IDEX, and they have all the profiles for all the filaments that we sell at visionminer.com. If you want to see all the different materials that we sell that this machine will print, then go to visionminer.com/materials. You'll see our entire catalog up there, and sometimes there's some new stuff we're testing in the back. So if you really want to know, give us a call or shoot us an email. Next, advanced, we are using a 40% overlap on the infill perimeters. So with the infill to the perimeters, it's gonna overlap. Now this part, I don't think really has any infill per se. In filaments, okay, so we're in here, we got extrusion multiplier set to 1.1 and the bed set to 90. Let's reset that back to 130, there we go. Okay, so now let's go in and go ahead and let's go slice our part. Okay, here we go. We can see the part in its entirety. I always like to skim through the layers. Sometimes you'll catch something where it's like, why are there a bunch of little dots right there? What's it doing? And often that'll be a problem with the STL file, which can then be repaired, and then that will not show. But you always want to look at your tool path. So let's check it out from the top down. We got the holes, all right. As you can see, we're all perimeters. There's no actual infill happening here, so this is gonna be a very solid part. Go all the way down, and then we start to see the interface layers. Beautiful. Okay, so one cool thing is you can see, there's the tree support coming up, right? And then at a certain point, it makes this like flat layer, and then it starts building the actual part. So there's a bunch of solid layers that then support the actual part layer. And then you can see it again once we get up to Right there, you see it building over on this side. And then it just connects, and then boom. Your overhang is this whole section. So you got 2 full perimeters, but then it's going to put a patch on top of that and fill in that whole gap. And then it's gonna start building back into the part again. So here we have it. We're ready to go. Solid. Let's go ahead and export the Gcode, send it over the machine, and get this print started. Export. I'm going to save this. All right, let's just go to desktop, and we'll call this the NACA duct, 12x5G. Okay, nylon. Very good, and save. And then we'll go back to our machine, and I'm going to go to jobs, and then I'm going to go upload Gcode files. So we'll take this, and we'll go over to our desktop. We got our file right there. We're gonna go ahead and open. The next most important thing is that you dry the heck out of your filament. Any filament, any plastic will absorb a certain amount of moisture, and that moisture from the atmosphere of the air will saturate it at a certain point. And if you melt that filament, especially through a tiny little nozzle and a pressure system, it will expel steam, which will then cause bubbles, and that will cause extremely poor surface finish, massive stringy oozes, and all sorts of other stuff that you don't want in your print, and it'll make it weak and all this stuff. So you want to really make sure to dry your filament, especially nylon. Now, what do you need for this? You need an oven and a vacuum chamber to do it most effectively, or better yet, a vacuum oven, all of which is available at visionminer.com, so check it out. We got all this stuff available for you to make your 3D printing and digitization life easy. But for now, we've got this handy dandy vacuum chamber with my filament in it. So the filament was baked and heated in the oven, and then it was placed into the vacuum chamber. You pull vacuum, and it lowers the boiling point of the moisture in the filament to off-gas it and get it all out of there, and then you're ready to print. So what we're gonna do now is we're going to take the spool out of here, set up the machine, and load the filament. So let's do that. Over here on the machine, I'm gonna go ahead left heater, I'm gonna hit load filament, and we're going to do nylon. All right, so now it's gonna heat up the nozzle. I'm gonna go ahead and grab this. Now my filament is gonna be warm because it was just in the oven. So I'm gonna grab it with a glove on. All right, and now the machine is heating up the nozzle to 290 Celsius. So what I'm gonna do is I'm gonna get this into the machine in the proper orientation. I'm gonna have it coming off that way, so when it is hanging in here on the chamber, it can just go up into the hole and unspool like that. So I'm gonna grab my filament. What you really don't wanna do is let this loose. If it gets all loose, it gets all crazy, and then this little end gets wrapped under another one, it's really hard to see that it got wrapped. It's like virtually impossible most of the time. And so what'll happen is you'll start a 16-hour print, and an hour 15 and a half, it's finally gonna have enough tension, it's gonna snag, and it's not gonna extrude anymore, and you'll come in and your hot end will just be above the part printing in air, and you'll be like, what happened? And you'll be like, you'll look around my settings, and you'll be like, oh, the filament tangled. So be really diligent, guys, really careful every time you load your filament to make sure this end, you know where it's at all times. All right, so let's go ahead and place this on the holder in here. And then I'm going to feed it up into the machine. And I'm just gonna keep one-handed, feeding it up, feeding it up, feeding it up. And then as soon as I feel it stop, I'm gonna hit the extrude button. Okay, there we go. It has stopped. So I'm gonna hit extrude, the screen. I'm gonna feel it back here, and it's loading. I'm gonna look at the nozzle in just a moment. It's gonna start spewing out, so I'll close my door now, just to keep all that heat and heat soak in there. I'm gonna watch the nozzle. There it is, all right. It's coming out. Very nice. All right, just for proof, guys, we got this tiny little bit of filament coming out here. Oh, yeah, there it is. And right when I do that, it stops, of course. So I'm gonna get rid of that. because we don't need all of that in there. So do I see new filament extruding? Yes, I do. It's done. We're loaded. So that's really all there is to it. Our filament's loaded with dry filament. The machine has been preheating. It's up to temperature and the frame is heat soaked. I've got my slice dialed in and optimized for my settings. I've got that loaded onto the machine. All that's left is to hit print, and then we'll come back and take it off the plate. So all I gotta do here, you get this nice little preview if you hover over of what it is. I'm gonna go ahead and click that and hit yes. Now, it is still important to spend a few minutes, 5-10 minutes at the most, by the machine. Don't just hit go and run out the door and go to your event. Usually it's a good idea to watch the first layer and make sure it's going down properly. And what I'm gonna look for is that I'm gonna make sure that the layers are even, they're barely touching, they're just looking nice and smooth. All right, so it's done with auto leveling, and now it's gonna bring the temperatures up. Here we go, okay? So the nozzle's ready to print. Here we go, here's our first layer. There we go. There's that beautiful first layer. All right, so we're back and we already took the first one off. Let me show that to you right here. Beautiful part, came out very well, but you might notice a little bit of weird stuff down there, and that's because the supports that we painted on was just too much. It was a little bit overkill. There's a couple things about that that I want to show you and go over real quick. Firstly, we had the supports going all the way up into this little crevice here, and they kind of got stuck. Part of it was the support settings, but we just revisited this. So we did another slice. We actually sliced and tuned the supports, and we found out during that process that really this area down here, these two angles, as it's sitting on the plate, you can sort of see there, they're both good. The overhangs are just fine. There's no drooping or anything like that. And then the bridging section, that chasm that it needs to bridge across, is so short that you really don't need supports there. So we went back and we modified it to just support this front little lip. As you can see, this fits perfectly right there, and just supported it like that, and then the whole thing came off in a chunk. There was one little part we missed there that was still up there, so we got rid of that, did it again, and got this nice interface layers to support the whole part. From there, we said, all right, it's looking great in this little area, so we printed the whole thing again, and it's ready to be taken off the plate. So I'm gonna get my tools and everything real quick, and we'll do that. All right, so I've got my gloves, just because inside the machine's usually hot. Now we already turned the build plate off, so the plate has cooled down a little bit. The chamber's been on, just to anneal the part a little bit, and so we'll just go in there and bring it over. Let's do that now. It is easy. We're just gonna undo the thumb screws on the build plate, and then slide the plate right out. Then I can actually turn the machine off. So here we have it. Worked extremely well. You can see how well that Nano Polymer Adhesive works. Toss me the back. Oh yeah. So this stuff we developed about 5 years ago, and it works incredibly well for almost every polymer on the market and nearly every machine on the market. So if you have any issues, build plate adhesion, warping, curling, anything like that, pick up a bag, satisfaction guaranteed. You will love it. Now, this activates at high temp, and the plate is still pretty hot because the chamber is hot. So I could let it cool down and it might crack, but this one I think will be really easy. I can just set this on the edge of the table and give it a little bend. Boom, right there. And I'll do it the other way just for good measure. And the part's ready to come off. Now, looks like the support is still stuck, so it might actually come off. Ha, look at that. Beautiful. Beautiful. Supports came off perfectly. Okay, if I want, I can clean up my build plate off here. Just use a scraper. Whoops. There we go. So, I can now remove the gloves. We've got all the support material. This is like, what, a gram or two? Probably like 4 or 5 grams. And the part itself came out beautifully. Absolutely phenomenal. There's 2 of these actually installed on that Porsche right now in service, and they've been working great. So here we have it. That's the process for printing in CF-PA6 or Nylon 6 with carbon fiber on our 22 IDEX. If you want to learn more about this machine, give us a phone call or shoot us an email or go to visionminer.com/22IDEX. There should be a link in the description down below, and all the specifications, use cases, examples, all kinds of stuff is there, and we're happy to help with your project as well. We'll prove out the machine if you're considering it, or just answer any questions you've got. Also, one of the big things is selecting the right material. Not going too far in the upper end engineering materials and making it more difficult than it needs to be for your own projects. A lot of the time, something like PA6 actually will work. Other than that, thank you guys for watching. Leave a comment down below, like and share this video if it can bring value to somebody, and have a positive rest of your day. I'll see you on the next video.